So don't forget in lesson 12 here we talked about hydrogen ions, or aka hydronium ions. In solutions, basically. Okay. When we talk about pH, pH is another measurement of the H plus concentration, or as we know from yesterday, probably a little bit more accurate, the H3O plus concentration. Okay. Those basically are the same thing. H plus added on to water, of course. We said the greater the H plus concentration, the higher, the more acidic it's going to be, and the more acidic, of course, the lower the pH would be as a result of that. We talked about water there a little bit as well. Okay. Don't forget as well, if you have a pH of 3, for example, that is technically 10 times more acidic than a pH of 4. If you had a pH of 3, it's 100 times more acidic than a pH of 5. Every time you move up or down 1 on the pH scale, you are moving up and down by a factor of 10. Okay. So 10 times more acidic, or 10 times in some cases more basic, or 10 times weaker, whatever the case might be. We got to this yesterday here, and we did this in class. We talked about the pH and how that's related here to the concentration. The other formula, of course, that you're going to see on the periodic table here, or on your periodic tables on the back there, is actually that one there, right? So the negative log of the hydronium ions. Same thing, means the same thing, but we will use, of course, probably the H3O plus one is the one that you'll find on the back of the periodic table. Okay. So to figure out the pH, if you have the H plus concentration or the hydronium ion concentration, really means the same thing. If you have that, you're going to take the negative log of 1 times 10 to the negative 7 in the first example here. You're going to type that in, right? And remember from yesterday, of course, there we go. Negative log, so you're looking at negative log, okay, 1 times 10 to the negative 7. So it would look like that there, okay. Hit enter, and that'll give you your answer for those there, okay, in this case 7, of course. All right, so don't also forget, another thing is we need to talk about significant digits, which is very important as well, okay. In this case here, we have 2 in the concentration right there. So we have to have 2 after the decimal when we write out pH. So those 2 significant digits are actually those ones right there. Okay? So remember, it's after the decimal that matters. Okay? This one here works out to be 3 when you type it in on your calculator. So it's 3.00. Those 2 there are those 2 right there. Okay? 11 is the next answer here. Once again, only the 0.00 is the significant part of that. So because we have 2 there, we need to have 2 after the decimal. Yes? 6 times 10 to the negative 8, that's 1 significant digit. So we need to have, as an answer here, I think you get 7.22, if I'm not mistaken. So we only need 1 significant digit, so only 1 after the decimal, 7.2. Okay. 3.5 times 10 to the negative 3, what does that work out to be again? I forget what was that? Yeah. 2 point what? Really? 2.46, isn't it? Yeah, 2.46. Close. Maybe just rounded too much there. I don't know. Or maybe just typed it in a little bit wrong. And 2.46 is what you'll get for that one. What about the last one here? Do we have that one? 8.74? Is that right? Yeah? Okay. I always forget the last one here. 8.7. Well, I forget the last 2, I guess. 8.74. Okay? So that's what you should get that for those. Okay? Now, we can go back and forth between these. As you know, we used logarithm to get from the concentration to the pH. There's a formula that will get us from pH back to concentration, which is eventually what we need to be able to do as well. So that's on the next page here, right here. Now, mine didn't show up for some reason, but you guys have yours here somewhere. So if you are looking for the concentration of H plus or H3O plus, Okay, either one, same thing, right? Just different definitions. One was H plus was the Arrhenius definition. H3O plus is the modified definition, right? And we're going to talk a little bit about that again today when we write out some equations here for these. You would take 10 to the negative pH power, okay? So for the first one, for example, you'll just simply type in your calculator 10 to the power of negative 2 pH, okay? So for this one here, 10 to the negative 2.00, and you enter, and you get 0.01, okay? So that's how you're going to do these calculations here. So I'll give you some time. You guys can do those. With the first one, look, that's the answer. Okay, listen. That's the answer, 0.01 moles per liter. But we do have to keep in mind significant digits. Now this one's kind of the trickiest one. I probably should have put this one somewhere down at the bottom here. But remember, what's significant in the pH here? Where are the significant digits in pH? They are after the decimal, yes? So how many significant digits do I have in that pH? And the answer is 2, right? The 0.00 is the only significant part of the pH measurement. So in this measurement here, I am focused on 2. So therefore, I need to have 2 in the concentration. Hey. So we only have 2 there, so we need to have, once again, okay, 2 in my answer. I don't have 2 in my answer, do I? I have only 0.01, so I need another, well, I need a 0 at the end here, okay? So 0.010, because the zeros in the front don't count, right? Zeros at the end do. So in this case, I need to put another 0 on there. Okay, and you can put another 0 in front of here if you want to hold the space, that's fine. But that's what your answer needs to be. That's the only tricky one that we have there. Other than that, they're pretty much all straightforward. So go ahead and fill the rest of these in here real quick for me, please. All right, so there's your answers there for that, okay? Like I said, you just simply type in 10 to the power of negative pH, right? Whatever that happens to be, okay? So copy those down very quickly here, and we'll move on into some actual questions here, what you can kind of expect for today. We're not going to get this all done today, so I'm going to give you guys some questions to work on over the weekend. Your test, Unit 3 test, will be on Monday, December 9th, so that's a week from this coming Monday. So that'll give you enough time to study and enough things for us to, enough time for us, I guess, to finish up a few little things here and there. And we have one more lesson after this, but it's a quick, very quick one. And then we go to the lab right after that on the same day, and we do that in the lab as well. Okay? So we'll talk about that coming up here. Okay. So we're going to focus on pH first of all here. pH, of course, you guys know pH, right? We've dealt with pH before. We know that 0 to 7 is acidic. 7 to 14 is a basic solution. 7, of course, is neutral. We've discussed about H plus ions. Probably a little bit better definition would be this one right here, right? The pH is the negative log of the hydronium ion concentration, the H3O plus ion, which is the H plus attached to a water. That's really what we find, right? So this is the formula, like I said. You will find that on the back of your periodic table, and you will find the other one as well. The one we just did with 10 to the negative pH gives you the concentration of the hydronium ion. You'll find those two on the back of your periodic table. Some of the questions, when we kind of start out here, will look something like this here. Calculate the pH of a solution with a hydronium ion concentration of 3.8 times 10 to the negative 3. Is this solution acidic or basic? So these are the types of questions, some of the types that you'll get today. Okay? Basically, these two examples are going to take care of that for you today here. If you want to find the pH, you need to know this concentration, okay? pH is a direct measurement of the concentration of the hydronium ion. Remember, I think I told you the other day here, those two things are really the same thing. Concentration of hydronium and pH really mean the same thing. They're just in different units, right? pH converts it to, 0 to 14 kind of thing. or we got concentration, right? Same thing, but just in different units. So we have the hydronium ion concentration, so I'll simply just enter that number right here, and this is all you have to do with this one. And we're going to just type that in on our old calculators there. Let's see, negative log 3.8 times 10 to the negative 3. There is a reason why we're being so simplistic here. You might say, well, gee, that's all I got to do. That's easy. There's a reason for why we're doing this, and you'll find out when we get to Monday, okay, when we finish this off here, because they don't always match up and stuff. We'll talk about that. 2.4202 is my pH that I get from that, and we have to do significant digits, right? So we look at the concentration in this example here, 3.8 times 10 to the negative 3. That's 2 significant digits. I need to have 2 after the decimal in pH, okay? Remember, in pH form, only after the decimal counts, okay? So 2.42 would be your final answer. That's what you would write down. And yes, well, I'm going to tell you right now, will you get a question like this on your test? Yes, you will, okay? Pretty straightforward. This is what we call the gimme question, okay? So you would write down 2.42 in numerical response. Now we get to a question that looks like this here, okay? Calculate the pH of a solution by taking 3.75 grams of HCl and enough water to make 250 milliliters of solution. Is this solution acidic or basic? So, HCl. Let me ask you some questions here. Does pH measure this? Does pH measure HCl? Yes or no? What do you think? Yes, okay? If you actually, by the way, this is a gas right now, okay? If you take a pH meter or pH paper and you stick it in HCl gas, you know what you get? Nothing. Because HCl is not an acid. Yes? We've talked about this numerous times. If you're confused, well, I'll fix it for you right now. But it's also not good. HCl is not an acid until you put it into water, because then HCl can ionize. So, should I measure the pH of this? And the answer is no. Okay? I need to do one of two equations, I guess you could say. One, according to Arrhenius' theory, he said HCl would give you H plus ions and Cl minus ions. That was his first definition. And then remember, through numerous studies, he said, guess what? Can't find any H plus ions in that water. So we have to adjust it a little bit. So probably the better definition is when water is a reactant, okay? So yesterday we talked about these types of equations, right? We said, hey, HCl, when you put it into water, it ionizes into H plus ions and Cl minus ions, okay? The H plus ion attaches itself to the water. So this attaches it to this, and it makes, well, H2O, and add an H plus on, H3O positive, hydronium ions. Now you have an acid, okay? What's left over? By the way, if you're doing any of these equations, they're all identical, okay? The H plus attaches itself to water. We're making an acid. What's left over? Cl minus in this case. So we put down here Cl minus. Yes, Lucas? Yeah. So that is the equation we need to write out, okay? Now we have an acid because the HCl has ionized, broke them apart. The H plus has added itself to water, and now we have the hydronium ion. What does pH measure? Does it measure this? No. What does it measure? Where should I put pH in this? Yeah, that is the pH there, right? pH and H3O plus, remember, are the same thing, right? They go together. All right, that is what you're measuring. When you stick the pH meter in or the pH paper in, you're measuring how many of those you have. Okay? So we need to make sure we put the pH there. Okay? These questions, okay, other than the fact that, okay, we got a little bit of a fancy equation here, if you want to think of that. We added water into here and we made it a little bit fancier. But these questions are exactly what you did about 2 to 3 days ago. Concentration of individual ions. Yes? Gave you a worksheet on those with some answers along the side. That's what this is, with one extra step at the end. That's all it is. You're going to put down the information in the right spot. 3.75 grams of HCl, probably should put it here, yes? 3.75 grams of HCl. Where should I put 250 milliliters of solution? What do you think? 250 of solution. Where do you want to put that? Now you could make an argument here in this case. Where does the 250 go? Well, when we did this a couple days ago, we said it goes everywhere, right? Yeah. Could you still put it everywhere? Yeah, you probably could. Okay, because ultimately this HCl is going into 250 milliliters of water at some point. Okay, so you could put 250 here. You know, you might argue and say, well, no, it's not until you add it to here. Ultimately, though, at some point in time, you will have 250 milliliters of solution at some point in time. And you know what? If you want to put it on the first one here as well, by all means do so, okay, if you really want to. I don't honestly care. All this is going to take place in the same amount of solution, okay? You're going to have to put 3.75 grams of that gas into 250 milliliters of water at some point, okay? Okay, so let me ask you this. This is kind of what I've been given here. I'm going to actually just take this off for a second here, okay? So, you know, we write down the information in the right spot, right? We balance chemical equation by the way it is, okay? We write down all the information we have. It says calculate the pH. So the first thing, of course, that we did last day, we said, where should I put that? What am I looking for? pH is a measure of this, so that is what we were looking for. Then I think to myself, if I want the pH, what do I need to know? If I want pH? Concentration. So maybe I should find the concentration of this. If I want to know the concentration of that, what else do I need to know? N, right? Yeah, moles. N. And V, of course. And hey, I already got V. How about that? So I need to find N somehow. Well, how can I find N? Well, what other information do I have here? I got mass. I could use the molar mass to find N. Yeah? So 36.46 grams per mole there. Let's see. I better just do this here because I'll forget again. Yeah, it's 0.1028 moles here. Okay? And we do exactly like we did with concentration of individual ions, right? So if you guys did that okay, we'll do this okay. 0.1028 moles here. So I got 0.1028 moles of acid. And guess what? HCl happens to be a strong acid, and by the way, we'll probably only do strong acids because weak acids are different. We'll do that next year in Chem 30. But remember, what happens with a strong acid? It completely ionizes. So if I get 0.1028 moles here, then how many moles do I get here? The answer is 0.1028 moles. Okay? It's a 1-to-1 relationship. Okay? Now, I will say this, and hopefully I don't confuse you, but listen carefully. Sometimes you guys get this mixed up here for some reason because you look at 1 here and then you see 3 H's here. That has nothing to do with it. Okay? It goes based on the balanced chemical reaction. For every hydrogen ion here, it attaches itself to water to make 1 hydronium here, right? It's a 1-to-1-to-1-to-1 ratio here, okay? That's what we're looking at, the ratios out front, not, you know, hydrogen to hydrogen kind of thing. You can't do that. You got to go based on the balanced chemical equation like we've always done, okay? So please remember that. And by the way, we only do monoprotic acids in Chem 20. So guess what? It's always going to be a 1-to-1. Okay? Even if it was polyprotic, the first equation would be a 1-to-1. So it doesn't matter. Okay? So don't worry about that part. Okay? So 1-to-1 times 1. We got N and V, by the way. So divided by 0.250. We get 0.4114. Now we have the concentration. How do we find pH? We take the negative log of the concentration. So we take negative log of 0.4114. Okay? So negative log of 0.4114. And remember, don't round these numbers at any time. I'm still not going to round it now. This is still 0.385725 okay? And now I finally round it, okay? Now I will finally round it here at the very, very end. And this is what you would want to put in your numerical response when I ask this question, yes? So we have to go back to the beginning of the question here. How many significant digits do you have? Well, you got 3 and 3, right? So we have to keep this in mind here. We got 3 and 3. So 3, 3, 3, 3. If I asked you what the concentration was, you would have 3, yes? Okay? So when I go to do pH, remember, if I have 3 in the concentration, I need 3 in the pH after the decimal. So in this particular case, your final answer should be 0.386. Now that wouldn't work in a numerical response question because you wouldn't have enough room to write that. Okay? So obviously I'd have to make either one of those. I'll show you basically later on here. But okay? 0.386 would be your final answer. Now, remember the 0 on the front doesn't count because it's pH. But even, I'll show you the next one where it's a little bit more relevant there. But 0.38, remember 0.386 after the decimal, 3, so 3, right? 3 concentration, 3 after the decimal, okay? That is nothing more than concentration of individual ions with one extra step at the end where we took the negative log, the pH, to find the pH, right, of the concentration. Now, we're going to do this, like I said, Monday, Tuesday-ish, roughly, so I don't really want to talk a lot about this, but there is different ways of measuring pH, by the way. Litmus paper, pH paper, pH meters, indicators, which we'll do coming up here Monday, Tuesday. So that's all that tells you about there. There is another thing that you guys maybe never have heard of yet, okay? And that is called pOH. So you can find the pOH as well of a solution in some cases. pH refers to H3O+. Well, pOH refers to OH-. Okay? And I'll show you why that's relevant coming up here. You're just going to have to wait for one example. The formulas are all the same, so the formulas don't change. pOH is equal to the negative log of the hydroxide ion concentration, whereas pH, right, does the negative log of the hydronium ion concentration. Okay? So pH refers to that, pOH refers to hydroxide. Okay? And I'll show you why in a few seconds here. One of the things about pOH is this, though. It is basically the opposite of pH. So when we think about a pH between 0 and 7, we think of acidic, right? When we have a pOH between 0 and 7, it is basic. It is the opposite. If you take the pH scale and you flip it over, that's the pOH scale. Okay? So pOH now is from 0 to 7 is basic. 7 to 14 is acidic. It's the opposite. Okay? And there is some similarities there, and we'll talk about that once again on Monday. We're not going to have enough time today. Okay? So how do you calculate pOH? Well, you have to have, of course, the hydroxide ion concentration. So if I want to do this one right here, we simply take the negative log of 6.8 times 10 to the negative 5. And since I'm looking for the pOH, and this is hydroxide, those match up. Good to go. Simply type it in. Okay. Negative log, right? 6.8 times 10 to the negative 5. And we get 4.16749, etc., etc. Significant digits, yes. 2 in the concentration, 2 after the decimal. Okay? I'm going to tell you right now, that's going to be a question on the test eventually. Okay? Going to give you something just basic like that to do. Ask you what's the pOH of the solution, and maybe, you know, I don't know. Well, I don't know if I can work this in or not, but is the solution acidic or basic? Well, it's a pOH of 4.17, which is between 0 to 7. This is basic. Okay? Because we are talking about pOH. All right? Good? Question? What? We haven't even started yet. No. Now, let's look at this question here. Calculate the pOH of a solution of barium hydroxide. Okay? Now, have you guys ever heard of pOH before? Probably not. Okay? Why are we calculating the pOH? Is there a way, what can we do with the pOH? Well, you'll have to wait till Monday, and I'll tell you. However, look, if we got barium hydroxide here, here's barium hydroxide, and that's a solid, by the way. Okay? Barium hydroxide, we need to find the pOH of this solution, it says. When you put barium hydroxide into water, you get this and this. Concentration of individual ions again. Yes? Because barium hydroxide is technically an ionic compound, it dissociates. Okay? Now, there's a couple things I need to tell you about this here. First, you might say, why are we writing this? And why didn't we include water? Like we did, you know, like the last one we did, we put water on there, right? We put HCl plus, H2O, H3O plus, and Cl minus. Do I need to include water with this one? Should I have maybe written barium hydroxide plus water gives me something, something? Do I need to include that with this one? Yes or no? Well, it goes back to the definition yesterday. The definition of modified Arrhenius theory is it can dissociate or react with water to produce hydroxide. Okay? It can dissociate or react with water to produce hydroxide. Does barium hydroxide, this is a silly question, does barium hydroxide have hydroxide built into this formula? So do I need to add water to it to get hydroxide? You need to put it into water so it breaks up to give you hydroxide, but there's already hydroxide built into this, right? Remember the other day, so this is fine. This is part of his modified definition of what a base is. Barium hydroxide can dissociate, which this is exactly what we did, concentration of individual ions last day, dissociates to give you these two ions. If you'd had NH3, can I just simply put that into water and get hydroxide? No, you have to react it with the water to show me how you get the hydroxide, right? So you would have to add that on. And this is a weak base, by the way, so we're probably not going to do that with these anyway. Yeah. This one? Yes. Okay. And it's already got the hydroxide there, so we don't have to worry about adding water to form hydroxide. It's already part of that ionic compound. So this one just simply dissociates. Okay? So this is perfectly fine. Secondly, why are we talking about pOH? Well, let me ask you this. Who's heard of pOH? Do we have pOH meters? Probably, well, we probably do somewhere, but we don't, okay? But look up here. Does it make sense to talk about pH with this? What does pH measure? What's that? pH measures power. Yeah, power of hydrogen or hydronium ion. Do you see hydronium ions up here? No, because it's a base, right? Hydronium ions are for acids. This is clearly a base that's got hydroxide built into it. So should we be talking about pH with this particular one? Hydronium ions? No, we should be talking about POH, because there's hydroxide here. Now you might say, well, okay, but I've never heard this term before. There is a way to get POH converted back into pH, okay? We're not going to do that today. But look at this equation. There's no pH. There's no hydronium ions in here. So I shouldn't be talking about hydronium ions at this particular point. I'm interested in the hydroxide ions. So once again, you would say, hey, the 0.50 grams would go here. Okay. Where can I put 375? Anywhere you want. This is all taking place in the same beaker, if you wish. Okay. So anywhere I want. Calculate the POH. The POH refers to hydroxide ions, right? So where am I going to calculate this? Right here. Makes sense. Yes? That's the hydroxide ions, because now that's what I'm measuring in this water solution. Same question exactly as before, guys. If I want POH, I need to know C. If I want to know C, I got to know N and V, and I got V. How am I going to find N? Well, gee, I got the molar mass here, 171.35 grams per mole. I can find N. So exactly the same as the last one, okay? And we get 0.0029 moles. Now, this is where you have to be careful. Where the acids will always be a 1-to-1 ratio, these can be a 1-to-1 ratio, but they can also be more than that. And I will probably ask you, okay, this one, because this is the one that you're going to mess up on. Because that's who I am, right? Look, this is a 1. This is still a monoprotic base, because anytime you put this in, you still get hydroxide as a when it dissociates. There's not another reaction where you get more hydroxide. So this is still called a monoprotic base. However, for every one of these, you do get 2 hydroxides. So we need to multiply by 2 here. Okay? And like I said, if you don't write out the equation, the chances of you doing that are probably not good, and that's when you're going to get the wrong answer. And that's why I'll ask you this. Sorry, but it's true. Okay? You'll get 0.0058 here, moles. Divide C and V there, of course. And it's not because I want you to get the wrong answer. It's because I want you to realize that the equations are important here, right? Get about 0.01156 or 156 moles per liter. We take the negative log of that, of course, right? So to find the POH, we would take the negative log of 0.01556, and we would get negative log 1.807915. Okay? And then significant digits again. Now, this one's a little bit trickier. How many significant digits are here? The answer is 2. 3 here, right? So 2 and 3, we got to go with 2. So we say, okay, 2 significant digits, 2 significant digits, 2 significant digits for my concentration. Therefore, I need 2 after the pH. Or sorry, after the decimal here. So 1.81 would be your final answer for this. 2 after the decimal. Okay? Yep. No, pH doesn't have units. Okay? pH is just a scale, basically. Yeah, so there's no units that go with it. There's nothing you can put there. It's just that number. That's it. Okay. Okay. Good. Those 4 examples that we did, the two really simple ones for each one, acid and pH, pOH, and these 2 last ones are exactly what you're going to have for homework today. Okay. I will mention a little bit. I'm actually going to take some of the homework off your load here. Just take a look at a few questions with me real quick here. 1A. Okay. By the way, I'm going to get you to do quite a few of these, but don't panic because this is how complicated it is. 1A. Okay. It says the hydronium ion concentration is 0.0027 moles per liter. Okay. Question 1 says find the pH. Well, okay. I don't even need to see a whole lot of work for this, guys. I need you guys to put this in on your calculator and come up with an answer. Okay. That's all you need to do. So you're going to type that in. You're going to get your answer. Done. Okay. Is it okay if I do that? Sure it is, because pH measures H3O plus, and that's what we have here. So we type that in, negative log 0.0027, and we get 2.5686, and 2 significant digits there, so 2 after the decimal. Done. Okay, that's all you need to do for the first few. But then we get down to D. Okay, and by the way, there's some word problems here too, you guys can see. Some of the word problems are exactly like 1A. You will just be able to punch that in your calculator and you'll be done. Some are not. Okay, we get down to D, and it says the concentration of HI, otherwise known as high, is 9.7 times 10 to the negative 5 moles per liter. Okay? Now, should I type this number into my calculator right off the bat here? That's the question. Can I just take this negative log, punch that number in, and get an answer? What do you think? Yes or no? No, yes, and you're both right. Okay? What I need you guys to understand, though, is this. Okay? You will get the right answer either way. However, listen. Does pH measure this? We should know that it does not. Okay? That's what you need to understand here. pH measures, so really with this question, I would like to see an equation. Am I going to see this on your test or whatnot when it's multiple choice? No. But I need you guys to understand that this is not an acid. pH doesn't measure that. It doesn't measure the water. It measures this. Okay? Oops, sorry. That's an I there. I'm used to. Okay? pH measures that, right? Okay? So in this question here, we're told this concentration here, 9.7 times 10 to the negative 5 moles per liter. Okay? Now, that's what I'd like to see for this question. Okay? Or any question that looks kind of like this, where you have HI or sulfuric acid or hydrochloric acid, whatever. Because really that's what's going on here. Okay? Having said that, look. This is a strong acid. Hydroiodic acid is a strong acid, and that's the only ones we're going to do for Chem 20. So if this is a strong acid, this, right, completely breaks up into this and this, yes? So it ionizes 100%, roughly. So if this is the concentration here, now you might say, well, how am I going to get over to there? I don't have a volume. Well, you could pick any volume you want. You could pick 100 milliliters, a liter, 2 liters, 4 liters, because whatever this volume is going to be this volume and this volume and this volume, right? So if the concentration is 9.7 times 10 to the negative 5 here, it's 9.75 times 10 to the negative 5 here. And if you don't believe me, let's use 1 liter. Let's say this takes all place in 1 liter. I'd have 9.7 times 10 to the negative 5 moles. I move it over to here. 9.7 times 10 to the negative 5 moles divided by a liter, I get the concentration of 9.7 times 10 to the negative 5 moles per liter, right? the concentration is going to be the same. If it ionizes completely, the amount here is going to equal the amount here in the same volume. It's going to equal the same. So what do you do now? You take the negative log of 9.7 times 10 to the negative 5, and you're done. Okay? So do you get the same answer? Of course you do, because you're doing the same number. Okay? The important thing here to understand is, what are we actually measuring? Are we measuring HI for pH? No, we're measuring H3O+. Does that turn out to be the same number? It does. Okay? But I do want you to understand that when you're measuring pH, you're measuring H3O+, okay, not HI. All right? Now, if you look at 1E, okay, that there, you have no option. You will have to write out an equation for that, and that's like one of the examples we did in class. You have the grams, you have the volume, all that stuff. You got to figure out the molar mass, you got to move it over, etc., all that stuff, okay? So just be aware of that, okay? And like I said, there's some word problems where you'll have to do that, and there's some word problems where you can just punch it in on your calculator. The important thing to remember here, and it won't be an issue today, that and that go together, right? POH and this go together, right? Those go together. So we have to make sure. That's not going to be an issue for you today. And you are going to do questions number 1 to 12 for today. Do not go past there, because when you go past there, that's Monday. Okay? Now listen, one more thing. When you do one of these pHs, you're going to get a negative pH value. That is possible. I've told you that before. It is definitely possible. Okay? It doesn't stop at 0 to 14. That's the most common scale we use. It can go below 0, and it can go above 14. Okay? So just keep that in mind when you're doing these questions.